Okay, welcome. This video is going to explain to you all the different ways we can find the slope of a line. We've been working with the slope-intercept form, y equals mx plus b, for the last few days. So you should be very familiar with the m part of that being the slope. The m is going to be the coefficient, or the number, that's right in front of the x, no matter where it is in the equation. So you can see in this equation it's sort of in the typical format that we're used to. So the m is that 9, so the slope for this equation is 9. Here we have the slope just written second instead of first in the equation, but it's still whichever number is with the x. And you need to be very careful to include whatever operation, such as plus or minus, is in front of the slope. That goes with the slope. So here, this -2 is the slope because it's with the x. Sometimes the equation is written sort of in a funky way, and we're still going to look for where's the x and what's the number right in front of the x. That's the coefficient of the x, or that's the slope. So here it is. So m is -4. Again, kind of looks a little funky, but it's still where's the x, what number is with the x, that is our slope. So make sure you're familiar, or at least comfortable with, whatever format the equation is in, because we can have it in mx plus b form, but look sort of differently. The next way we're going to find slope is by looking at a graph, and we're practicing this today, and I'm sure you're very familiar with it, okay? Remember when we were looking at finding the slope, we were looking at finding how much is the change in y over how much is the change in x. Remember, this triangle symbol means delta. It's the Greek symbol delta, and it means change. What's the change? Okay? Remember the y, we do the y first because we always talk about doing the rise. How far are we going up or down first? Over the run. And we're always going to look at going to the right. Well, for this graph, my rise is, where I just need to pick a point to start. I can pick any of these points. I might pick this point right here. Okay, and how far do I have to go up to get to the next point? Well, I have to go up, it looks like 2, and I have to go over 1. So if I sort of draw an image of that here, to get from this point to this point, I had to go up 2, and I had to go over 1. So my rise is 2, my run is 1, so my slope is just 2. So I can say m equals 2. Okay? Here's the new part for some of you maybe. What if you don't have a graph of it, but you just have 2 points? Okay, well you could take these 2 points and plot them on a graph and then do rise over run and count how to get to them. Okay? Or we can use what we call as the slope formula. And it's this down here. Hopefully you've seen this before a little bit. The slope formula works the same way as our rise over run looking at a graph. Okay, we still have the change in the y values over the change in the x values. We still want to know how far are we going up over how far are we going over. Okay, the rise over the run. Well, the problem is, since we don't have a graph of it, we're just going to find the rise by finding the difference in the y values. Okay, if I was going from this point to this point, I need to find the y values. How far am I going from this to get up to here? So I just have to subtract the y values. That's what this is showing here. Subtract the y values. And then to find the run, how far am I going from here to here? I just need to find the difference in the x values. So I'm going to subtract the x values. Let's show what this looks like with these actual numbers. Remember, we always have x and y and x and y. Now the 2 and the 1 are just reminders that we're going to take the second one and subtract the first one. Just a little way that we do it. So if I'm going to follow this, I'm going to do the change in the y values over the change in the x values. So that means I'm going to do the second y value 12, subtract the first y value 8, over second x value 9, subtract the first x value 5. Well, 12 subtract 8 is 4. 9 subtract 5 is 4. And I can reduce this fraction to 1. So my slope is 1. The order that you put the points doesn't matter. So that's just a reminder for us that I could have listed these points 8, 2, 4, 10 versus 4, 10, 8, 2. We're going to get the same answer. So I just want to show you both ways just so that I can convince you of that. Still, again, the change in the y values over the change in the x values. And since we can't count them on a graph, remember we said we're just going to subtract the y values. So we take that second one first. 2 subtract 10 over 8 subtract 4. 2 subtract 10 is negative 8. 8 subtract 4 is 4. That looks like it reduces to negative 2. Same thing, different order. Let's see if we get the same answer. The change in the y values over the change in the x values. So subtract the y values. 10 subtract 2 in this case, the second minus the first. Subtract the x values. 4 subtract 8. That looks like it's going to be a positive 8 over a negative 4. Still going to get me that negative 2. So the order that you put the points in doesn't matter. Excuse me. Okay, let's look at a few examples. Same thing, and I want you, when you're doing your workout, to always write change in y over change in x as a reminder that the y's are on top, the x's are on the bottom. So when we talk about common mistakes that students make, one of them is switching the x and y around. So we need to be careful. Y's on top. Change in y, subtract the y values. 11 subtract 7. Change in x, subtract the x values. 10 subtract 5. 11 subtract 7 is 4. 10 subtract 5 is 5. I can't reduce that, so that's just my slope right there. That's my answer, 4/5. If I was graphing that, I would go up 4 and over 5. Let's look at the second example. Change in y over change in x. Subtract the y values. 2 subtract 11 over 7 subtract 3. Well, 2 subtract 11 is negative 9. 7 subtract 3 is 4. Again, can't reduce that. Just going to leave it right as that fraction. Negative 9/4. I'm going to go down 9 and over 4 in that case. A couple more examples to look at. The second most common problem that students run into, besides forgetting that the y's are on top and the x's are on the bottom, is we run into trouble with our positives and negatives. And that's very common, but doesn't mean we can't work really hard to overcome it. Here are some examples where we have some negatives, and let's look at how they work out. 2 subtract 8. That goes on top. Those are my y's. Negative 6 subtract a negative 5. Ooh. So 2 minus 8 is negative 6. When you subtract a negative here, negative 6 subtract negative 5, those two negatives together become addition. So we're going to have negative 6 plus 5, which becomes negative 1. Negative 6 over negative 1 becomes positive 6. So that's our slope there. So the reminder, if you're subtracting a negative, you can change that into a big plus. We're going to add those. It's like the opposite of subtracting is adding. Let's look at this example. Change in y over change in x. If we're going to subtract the y values, that's 2 subtract 4, the y values, over 6 subtract a negative 10. So there it is again. If we're subtracting a negative, that means we need to add. 2 subtract 4 is negative 2. 6 plus 10 is 16. Here we can reduce this. Notice a 2 goes into negative 2, negative 1 times. 2 goes into 16, 8 times. So there's our slope there. Hope this was helpful. Remember, if you're going to write down a couple of reminders. Number 1, change in y over change in x. Make sure the y's are on top, the x's are on the bottom. And number 2, if you're subtracting a negative, that becomes positive, adding. Good luck. See you in class.